Hello, and welcome to this fourth iteration on solving Sudoku puzzle by Peter Norvig. Yeah, initially we have seen that we are able to solve Sudoku of any size, and we have talked about the solution to that, how a grid is constructed and how it's validated, and how we are going to go about solving. Let me tell you one thing. We'll be using a recursive search algorithm known as backtracking search. It's a modified version of depth first search, in a way that if something goes wrong, automatically the last step what had happened, meaning the last stable state, it would the algorithm would return to that and start doing things differently from that. So, and now in this example, we have one of some hard really hard Sudoku puzzles that were given by mathematicians. That was given by Finnish mathematician Otto Inkala, and he described a puzzle from 2006 to be the hardest, and in turn, then in 2010 he created a puzzle that was that he claimed to be very difficult to solve. So uh, this program, my program here, refers to Mr. Peter Novick. So Peter Novick says that his program, that what we have seen so far, that's written to solve the problem, took only 0.01 seconds to solve this problem, right? Because it can think much faster, in much broader and faster terms, in comparison with the human mind. So, in order to prove that his algorithm is not a one-trick pony and it can do better in all sorts of scales, now we create random Sudoku puzzles and try to solve them. So, what's the algorithm that's used to generate random puzzles? So, we take the squares, meaning A1 through I9, and we randomly shift their values and insert those values into that. So, and there is also a slight, since there was a slight duplication of effort in that regard, Mr. Oliver George suggested that he used 8 different digits. So he incorporated that suggestions into his algorithm. So shuffle, so that would be pick from the order of 8 digits. Um, Shuffle them squares one by one, and one by one fill each square with random digits respecting possible digit choices, right? So if a contradiction is reached, start over. So this is also in order to generate the uh, Sudoku puzzle. That's the algorithm we are using. If there is a contradiction, we start over and we write a new puzzle altogether. That's because if one thing is wrong, it will lead to a multitude of failures. So that's about it. And here are some stats about how his random puzzles were received by the algorithm. So the average time to solve random puzzle was 0.01 seconds, and more than 99.95 took less than 0.1 seconds, meaning that he generated 130 a million puzzles, right? He generated a million puzzles using this algorithm, and out of which the general trend was the algorithm was really fast towards solving, but there were some anomalies that took relatively more time in comparison with this zero point 0.1 or 0.1 seconds, right? So these are the stats for that, and it's hard to draw. Yeah, he also says this, it's hard to draw conclusion from this because this is a generalized example. See, that's the intelligent question he's trying to ask. You see, if I generated 10 million puzzles, would it take 100 to solve? So what he suggests that is this solving of Sudoku puzzle, is that an intrinsically hard problem, or can it be can it be solved using programming techniques, right? So um, that's done and said. That's all done and said, and let's look at the small piece of code that Mr. Novik had written to verify the puzzles and generate the puzzles as well. So we see that solve all grids remains the same. So solved is another new method that we are seeing right now. So if a puzzle is solved if each unit is a permutation of digits 1 through 9, right? That's right? So we have to have a 9-digit number that's a permutation of all the numbers from 0 to 9 given any point, a row or a column or a 9 by 9 3 by 3 grid. That might be anything, but it should be a permutation of digits from 0 to 9. There might be any order, in any order, it doesn't matter. So solved checks for this validity, and this from file name is basically to load a file from the memory that we have and to the Python program, and this is the random puzzle generator that we are talking about. So that's about it. So this is basically input, cleaning the input, that's all it is. You take that and you shuffle and you return that sequence, and that's all it takes to solve the problems. And these are some impressive stats about how the size of the n varies the runtime, varies with the runtime, and that's about it, right? Thank you.